Alright, here's your guys' homework on solving and proving inverse functions. Okay, so for number 1, we have these coordinates right here, and it just says to find the inverse of these coordinates. So basically, to find the inverse of these coordinates, you just switch the x and y coordinates. So there's number 1. We just switched your guys' x and y coordinates. Now for these ones, they pass on the horizontal line test, and for every x value there is only one y value. So all we have to do is to find the inverse function's coordinates. You just put in the opposite. All right, so that's for 1 and 2. Now in your homework it says to start with number 11 to 17 odd. So we have this one, and you guys are going to find the inverse of this. So first we're going to switch x and y, and then you guys solve for your new y. So subtract 5 from both sides. And then what we're going to do is we're going to square root both sides. So we're going to get plus or minus square root of x minus 5 is equal to y. And we know y is just f inverse of x. So there's that one. 13, switch the variables, and now we're going to solve for the new y. We're going to square root both sides first. We're going to get plus or minus square root of x is equal to y plus 3, and then subtract 3 from both sides. And remember, this new y is really f inverse of x is equal to negative 3 plus or minus square root of x. 15. So it has a restriction, you guys, but simply we just switch our variables so that we're going to get a new restriction. Otherwise, you treat this the same. So x is equal to y minus 2. And this restriction also changes as well. Then we solve for a new y. So we're going to square both sides. And then we're going to add both sides by 2. So y is going to equal to x squared plus 2. And just so you guys get in the habit, this new y is our f inverse. So this is our inverse function. Okay. 17. So for 17, we have this. So we are going to switch them. Solve for the new y. So subtract 8 from both sides. And then we are going to raise both sides to the second power. So y is going to equal to x minus 8 raised to the second power. And remember, this y became an x. So f inverse is equal to x minus 8 squared. So that's 17. Okay, 19. This is where we are going to verify inverses. So remember, you guys, we have to do f of g of x, and we gotta do g of f of x. If both of these turn out to equal to x, then we have inverses. So first we're going to do f of g of x. So remember, you guys substitute in all in for that x and then solve. So we're going to get x minus 6 plus 6, which is simply just x. So that was just that. Now we're going to substitute this whole thing in for that x, for g of f of x. So we're going to get x plus 6 minus 6. And this is going to be and this is going to be x. So they both are x's, so that means these are inverses. 20. So again, f of g of x. And we're going to test g of f of x. So for this first one, f of g of x, we are going to substitute this whole thing in for this x and solve. So 5 times x minus 2 all over 5 plus 2. These cancel, so we're going to have equal 5 cancels, so we just have x minus 2 plus 2, which is just x. Good. Now for this one, g of f of x, that means we substitute g f of x all in for that. So we're going to get 5x plus 2 minus 2 all over 5, which is equal to 5x over 5, which is equal to x. So since both of them are equal to x, we know that they are inverses of each other. Number 21. So again, we gotta do f of g of x and we gotta do g of f of x. So first, we're gonna substitute g of x in for f of x. So we're gonna have negative 3 in parentheses negative 1/3 x minus 3 minus 9. We are going to be distributing. So negative 3 times negative 1/3, you guys, is just 1. So we're just going to have x. Negative 3 times negative 3 is 9. And this is equal to x. So that's good. Now we're going to do g of f of x. So for g of f of x, you guys, this is where you substitute f of x into your g. So we're going to substitute it into our x. So we're going to get negative 1/3, negative 3x minus 9, minus 3. So we got to distribute. Negative 1/3 times negative 3 is positive 1, so x. Negative 1/3 times negative 9 is positive 3, minus 3, and this is just equal to x. Both equal to x, so they are inverses. (22). Alright, so we got f of g of x and g of f of x. Alright, so we are going to substitute all of g of x into x. So we're going to get 2 times x plus 7 times 2 minus 7. These 2's cancel, so we're just going to have x plus 7 minus 7, which is just x. Okay, over here, we're going to substitute all of this stuff in for here. So we're going to have 2x minus 7 plus 7 all divided by 2, which is equal to 2x over 2, which is equal to x. So both of them are equal to x, so they are inverses of each other. Alright, 23. Same deal. So we got f of g of x and g of f of x. So f of g of x, you guys, you substitute this whole thing in for there. So you guys are going to get negative 4 in parentheses, negative 1/4 x plus 2 plus 8. Distribute this to both. So we're going to get negative 4 times negative 1/4 is x. Negative 4 times 2 is negative 8. And this is going to give us x. Okay, g of f of x. This is where you guys substitute f of x in for your g. So that means you're going to be substituting it into that x. So negative 1/4, negative 4x plus 8, close parenthesis, plus 2. Distribute negative 1/4 to both. So negative 1/4 times negative 4 is positive 1, so just x. Negative 1/4 times 8 is negative 2, plus 2, and we got x. So those are indeed inverses of each other. 24. So this, you guys, we got, what do we got? Oh, we gotta find f of g of x and g of f of x. So f of g of x first, substitute this whole thing in for the f of x function, so into the x, so we're gonna get 1/2 in parentheses 2x plus 14 minus 7. Distribute the 1/2 to both you guys, and you guys are gonna get 1/2 times 2, which is just 1, 1/2 times 14, which is 7. We're gonna get x. Okay, for g of f of x, you guys, you substitute f of x into your g of x function, so into that x. So we are going to get 2 times 1/2 x minus 7 plus 14. Distribute the 2 to both. And we're going to get 2 times 1/2, which is just x. 2 times negative 7, negative 14 plus 14, which is x. And we prove that they are inverses. Alright, lastly, so here's the graph. Graph the inverse for each relation below. Put your answers on the same graph. So if you guys plot this right, this is negative 2 comma 3. This is negative 1 comma 0. This is 0 comma negative 1, 1 comma 0, and 2 comma 3. So remember, in order to get your guys' inverse, you guys just have to switch and swap all of these coordinates, x and y. X and y coordinates, you just switch them. So we're going to have 3 comma negative 2, 0 comma negative 1, negative 1 comma 0, 0 comma 1, and 3 comma 2. I'm going to plot these now. So 3 comma negative 2 is right here. 0 comma negative 1 is right here. Negative 1 comma 0 is right there. 0, 1 is right there. And 3 comma 2 is right there. So this is what the inverse is going to look like, you guys. Just like that. Alright. 26. Let's find some coordinates. So I see that we got negative 1 comma 1 right here, 0 comma 0, and 1 comma negative 1. So now I'm gonna write down all of the ones that I'm gonna switch every single x and y coordinate so we can get our inverse. So 1 comma negative 1, 0 comma 0, and negative 1 comma 1. So I'm just gonna graph those. So 1 comma negative 1 is right there, 0 comma 0 is right there, and negative 1 comma 1 is right. Why does this look slightly off? Why does that look slightly off? I'm gonna test a random point because for some reason this doesn't feel right. Let's just do this one. I'm just gonna guess. That purple one I drew you guys, that one is like negative 1.5 comma 3. And over here it's like 1.5 comma negative 3. So if I made coordinates for those, it would have been 3 comma negative 1.5 and negative 3 comma 1.5. Let's see if that makes a difference. So 3 comma negative 1.5. Oh yeah, it does. And negative 3 comma 1.5. So my graph is going to look something like this. Okay. 27. Let's get some points down. We got this one, which is negative 2 comma 4. This one, 0 comma 3. this one, 2 comma 2, this one, 4 comma 1. Find the inverse of this. So we gotta switch every single x and y coordinate. So 4 comma negative 2, 3 comma 0, 2 comma 2, and 1 comma 4. 4 comma negative 2, 3 comma 0, 2 comma 2, and 1 comma 4. And there's your graph. Last one, 28, you guys. We got 0 comma 0, 1 comma 1, and 4 comma 1. Find the inverse. So we got 0 comma 0, 1 comma 1, and 1 comma 4. So when we graph it, 0 comma 0, 1 comma 1, and 1 comma 4. So it looks like this. Oops, I plotted that one wrong. This one should be at 4 comma 2. Alright, so 2 comma 4, and there we go. Looks a lot better. Alright, you guys, so hopefully that gave you guys some more insight on solving and graphing, solving, improving inverses.